Welcome back. Till long day after, today I will discuss continuity. Today I will discuss continuous function on a metric space, real line and separate variable. In my previous video, I have defined what is the definition of continuous function, what is the epsilon delta definition, limit definition of continuous function, what is the sequential criteria of continuous function. At first, I will highly recommend you, if you don't see my previous video, at first see my previous video. Then today's video would be so easy. Today I will discuss just as a review. At first, I will see what is the continuity on the real number. Continuity at a point. That means we all of us know. Actually, continuity at a point means there exists no break at this point. This is the meaning of continuity at the point. There is two definitions of continuity. One, epsilon delta definition. Second, limit. At first, I will see just as a review what is the delta definition of continuity. See a definition. At first, I will highly recommend you, if you don't see my previous video, at first see my previous video. Then today's video would be so easy. Because today I have defined this part just as a review. Because this part is very important for higher study, for topology also. Epsilon delta definition of continuity is, consider the space as a real number. Then the function f from R to R defined. Then consider a point x0 in the real number. Then f is continuous at the point x0 if given any epsilon greater than 0, there exists delta greater than 0 such that whenever absolute value of x minus x0 less than delta, that imply absolute value of fx minus fx0 less than epsilon. And this definition is always true for all epsilon. Just remember, what is the discontinuous function? I told you, for discontinuous function, always I will find one epsilon for which no delta works. And continuity means just opposite part. That means whatever epsilon I will take, for which at least one delta I will get, for which this work. And this work means this relation would be satisfied. Here x belongs to x0 minus delta comma x0 plus delta. That means if we consider this distance is delta and this point is x0 and this is the fx0, then this is with the x0 minus delta and this is x0 plus delta. And this is fx0 plus epsilon and this is fx0 minus epsilon, and this distance is epsilon. Here the image of this point always lies in this interval. By this graph we can tell this. That means whatever epsilon I will take, for this epsilon always I will get one delta for which this relation would be satisfied. Now I will see what is the epsilon delta definition of continuity between metric space. In metric space, consider two metric. Consider this is the metric D and this is the metric rho. And two metric, one from domain and one from codomain. It could be same metric or it could be different metrics. As for example, consider this D matrix is real line and consider this row matrix is discrete matrix, or vice versa. Consider this D matrix is discrete and consider this row matrix is real line. Here it is similar to real line. Consider f be a mapping from xd to y row is continuous at the point x, which be the member of the domain. Here the domain denoted as capital X. This function is continuous if for all epsilon greater than 0 there exists delta greater than 0 such that t of xy less than delta imply rho of fx comma fy less than epsilon. That means for this ball here x and this distance is delta, and here this is the ball and this is fx and this distance is epsilon. D of xy less than delta imply rho of fx comma fy less than epsilon means the image of every point of this ball by continuity always lie in this ball, this epsilon neighborhood. The ball contain the fx naught with the radius epsilon. So this distance definition is equivalent to actually y belongs to b delta x imply fy belongs to b epsilon fx. That means you can tell image of every element of this ball always contain this ball. So f of b delta x always contain this ball b epsilon fx. Okay, and from this subset idea we can tell for all epsilon greater than 0 there exists delta greater than 0, and y belongs to b delta x means y belongs to actually the inverse image of b epsilon fx. Y belongs to inverse image of the ball b epsilon fx. Therefore, for all epsilon greater than 0 there exists delta greater than 0, that imply b delta x always contain f inverse b epsilon fx. Okay, that means this ball always contain inverse image of the ball b epsilon fx. This is the definition of continuity in the metric space. Now I will see what is the limit definition of continuity. At first I will see in real line, then I will see metric space. Now I will see what is the limit definition of continuity. Actually, we all of us know what is the limit definition of continuity. Just as a review, what is the limit definition of continuity? Limit x goes to a, fx equal to L. If the function f is defined at the point x equal to a, that means if limit x goes to a, fx equal to this value of limit, if this is equal to f of a, then we can tell obviously our given function is continuity. Here now my question, what is the meaning limit n goes to infinity n equal to a and limit x goes to a fx equal to L? Here the convergence of sequence and here convergence of function. What is the actual meaning? We all of us know this is function and this is sequence. Sequence also be a function which defined only the point integer. And definition of convergent sequence is limit n goes to infinity a n equal to a. That means for every epsilon greater than 0, there exists capital N belongs to natural number such that n greater than equal to capital N. Distance between a n minus a less than epsilon, that means that imply if this is actually I have considered a real line. If it is another metric space, then this would be distance between the sequence an and a would be less than epsilon after capital N. We all of us know this is the definition of convergent sequence. And a function converges to at the limit point L means we all of us know. Now I will say what do you mean the limit x goes to a fx equal to L? In real line, this means for every epsilon greater than 0, there exists a delta greater than 0 such that absolute value of x minus a less than delta. That means actually distance between x and a less than delta in metric space, and this imply distance between fx minus a less than epsilon, and in metric space this absolute value imply distance between fx comma L less than epsilon. The definition of limit for this limit this imply, and given f be a defined function which is defined from a to r, where a is a limit point of the set A, then limit x goes to a fx equal to L means this condition is if and only condition for all sequence an which contain the set A such that an not equal to a, limit n goes to infinity an converges to a. That imply limit n goes to infinity f of an which converges to L, and this L is actually f of a by continuity, and f of a is actually f limit n goes to infinity n, and this value, this limiting value is actually a, and this is the definition of continuity. If this limiting value is equal to f of a, then we can tell the function f is continuous at the point a, and this idea has come actually from sequence. For all n which contain the set A, but n not equal to the point A, limit n goes to infinity if the sequence an converts to the point A. Then limit n goes to infinity f of an means actually put the limit, just interchange the limit here. Limit n goes to infinity an, and an means actually n converts to a. That means this is equal to f of a. That means this limiting value is equal to f of a. That means if limit x goes to a, fx equal to L, and if this limit is same as f of a, then we can tell the function f is continuous at the point x equal to a. Okay, I hope my all viewers have understood what is the relation of continuity with sequence. Okay, now I will say the sequential criteria of continuity. Actually, from this idea we can tell the sequential criteria for continuity. What is the sequential criteria for continuity? A function f which is defined from a to r is continuous at the point a if for every sequence xn which contain a converges to the point a, that imply f of xn actually converges to the point f of a. This is the actual idea of sequential criteria for continuity. As an example, now I will see one example. Fx equal to sine 1 over x when x not equal to 0 and 0 when x equal to 0. Now we want to find continuity at the point x equal to 0. For this, at first consider xn equal to 1 over n pi. Obviously this sequence xn converges to 0 as n goes to infinity. Then f of xn equal to sine 1 over n pi, which is equal to sine n pi, which is equal to 0. Notice at the point x equal to 0 the value is 0. So this is equal to actually f0. For this particular sequence, sequential criteria here has satisfied. But if we consider another sequence yn such type 1 over 2n pi plus pi over 2. Obviously yn goes to 0, therefore we can consider this sequence. Then f of yn equal to sine 2n pi plus pi over 2, and this value is 1, and 1 is not equal to f0 because f0 equal to 0. Therefore for this sequence we can break the sequential criteria, because sequential criteria is true for all sequence. If we can to find one sequence for which sequential criteria break, then we can tell our given function is not convergent at the point. So this function is not convergent at x equal to 0. Now I will see what is the continuity of multivariable function. At first I will see what is the limit on multivariable function, because if you know what is the limit of multivariable function, then you will understand in better way what is the continuity in multivariable function. Limit for vector valued function at a point. For this, consider a function f from D to Rm, which is vector valued multivariable function, which is defined on the domain D in Rk, and consider a tilde be a point such that there exists a sequence which converges to a tilde. Here a tilde is actually the vector valued function. Vector value. A tilde means such type a1, a2 up to an, and if ith component means fi of the function f, then fi obviously would be scalar valued function from D to R. And suppose for each I the limit x tilde goes to a tilde, fi x tilde exists and equal to li. That means in ith component the value of the limit of this function is li. Then define L tilde equal to L1, L2 up to Ln. Then if the limit x tilde goes to a tilde, where a tilde means a1, a2 up to an, if fx, here x tilde means here the vector valued function equal to L, and which is equal to f of a tilde, and then we can tell, since this limiting value is equal to f of a tilde, then we can tell this function is continuous at the vector valued function, vector valued at the point a tilde, where a tilde is vector. And from this expression we can tell this is actually equivalent to the vector x tilde is closer to a tilde, then fx tilde is eventually closer and closer to L. And if this L is equivalent to f of a tilde, then we can tell the function is continuous at the point a tilde. But if for some I, the limit fi at a tilde does not exist, then we can tell limit of the vector valued function at a tilde does not exist. And if limit of this vector valued function does not exist, then the function continuous, this is not apply when limit exists. Then if this value of limit is equal to the point of the function, then we can tell the function is continuous at this point. As for example, consider this function. Obviously this is vector valued function. Here limit xy goes to 0, 0. Here first component sin xy over xy. Second component x cube minus y squared x over x squared plus y squared to the power whole square. Now my question is, this function is continuous at the point 0, 0? For this, at first I will see, is the component y's limit exist? First, limit xy tends to 0, 0 sin xy over xy. Obviously this value is equal to 1, so this limit always exists. Second, limit xy goes to 0, 0 x cube minus y square x over x square plus y square to the power whole square. For this, I will consider one part y equal to mx. Then that implies limit x goes to 0 x cube minus m square x cube over x square plus m square x square to the power whole square, and this value is limit x goes to 0 1 minus m square over 1 plus m square whole square to the power x, and this value is infinity. That means this limit does not exist. And since this limit does not exist, then whole limit of this function does not exist. And since limit does not exist, that means the function not continuous at the point 0, 0. What is this function? fxy equal to x to the power 4 over x to the power 4 y square when xy not equal to 0, 0 and 0 when xy equal to 0, 0. Is this function is continuous at the point 0, 0? For this, at first I will say the limit. But here limit means, limit at the point xy goes to 0, 0 means limit along the curve. Here we can tell at the point 0, 0 means we have to find the limit along the curve. Here we can consider one curve y equal to 0 means x-axis. Then limit when put the value y equal to 0, then this value would be limit x goes to 0 x to the power 4 over x to the power 4, this value is 1. And if we consider the path y equal to x square, along this curve the value would be limit x goes to 0 x to the power 4 over x to the power 4 plus x to the power 4, whose value is half. That means for two paths which goes to 0, 0, but I will get to different value. So we can tell this function fxy is not continuous at the point 0, 0 because limit does not exist. Limit does not exist at the point 0, 0. Okay. Next example, fxy equal to 2x times x square minus y square over x square plus y square. This is defined when xy not equal to 0, 0 and 0 when xy equal to 0. Is this function is continuous at the point 0, 0? If you see different path along the 0, 0, always in different path the value of the function would be 0. That means limit xy goes to 0, 0, the value of fxy would be 0, and this value is equal to f of 0, 0. So this function fxy is continuous at the point xy equal to 0, 0. Here also we can use the epsilon delta definition. How we will use epsilon delta definition? Let's see. Now take this part. This part is equal to 2x cube over x square plus y square minus 2xy square over x square plus y square. We can write this is equal to absolute value of 2x cube over x square plus y square plus absolute value of 2xy square over x square plus y square. Okay. Let epsilon greater than 0 be given. That means we have to show 2x times x square minus y square over x square plus y square, this value less than epsilon whenever mod x less than delta and mod y less than delta. Now take this part. This part is equal to 2x cube over x square plus y square minus 2xy square over x square plus y square. We can write this is equal to absolute value of 2x cube over x square plus y square plus absolute value of 2xy square over x square plus y square. Okay. We can write x square less than equal to x square plus y square and y square less than equal to x square plus y square. That means 2 times x cube means x times x square and x square less than equal to x square plus y square. That means this would be 2 times absolute value of x, because x square plus y square would be cancelled, plus 2 times y square less than equal to x square plus y square. This means 2 times mod x. This value is 4 times mod x. Okay. And here this is true whenever mod x less than delta. That means this is less than 4 delta. Therefore choose delta equal to epsilon over 4. For this delta, this is less than epsilon. Therefore our condition has satisfied. Epsilon delta definition has satisfied here. Means limit xy goes to 0, 0. The value of the limit of the function is 0, which is equal to f 0, 0. So the function is continuous at the point 0, 0. Okay. Now I will see fxy equal to y sin 1 over x when x not equal to 0 and 0 when x equal to 0. Is this function is continuous at the point 0, 0? Here, if limit xy goes to 0, 0, if the value of function fxy equal to 0, because at the point 0 the value is 0, then we can tell the function is continuous at the point 0, 0. Here also I will use the epsilon delta definition. Fxy minus 0 means y sin 1 over x. Choose epsilon greater than 0. This is obviously sin 1 over x always less than equal to 1. That means this value is less than absolute value of y. Now choose delta equal to epsilon, because this value is less than delta. Therefore, since delta equal to epsilon, this is also less than epsilon. Therefore, our given condition, absolute value of y sin 1 over x is less than epsilon whenever mod x less than delta and mod y less than delta. This condition has satisfied. Therefore, by epsilon delta definition we can tell limit xy goes to 0, 0, fxy equal to 0. Therefore, the function is continuous at the point 0, 0. Because at the point 0, 0, this value is 0 also. So, I hope my all viewers have understood how we have to find the continuity in multivariable calculus. Today I will stop here. In my next video, I will discuss this property and many theorems based on this property, because this property is very important for higher study. Okay, see you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.